My brand new Cosy 6 heat pump is up and running and has been for around about a week now. It's a short time frame, but it gives me some insights as to what to expect in terms of performance and what aspects affect the performance. I did a video recently covering the installation itself, so feel free to check that out. But moving on, just a recap about my house. It's a 2023 new build property. It has good insulation. It's a 4-bedroom with a space of 115 meters squared roughly. It has radiators in every room and also landings and hallways, so that makes 12 in total. But the downside is it has 10mm microbore pipes, which is always seen as a bit of a downside because heat pumps tend to do better with larger pipework. The Cosy unit itself is located right next to the property on the south side. So on to the technical specifications of the Cosy 6 itself then. It's a 6 kilowatt heat capacity unit, but the thing I'm more interested in is the SCOP and the efficiency. So the SCOP at its design temperature of 50 degrees is down as 3.4. Strangely, the efficiency is down as 310% and not 340, so not quite sure why there's a big difference between efficiency and SCOP. Maybe someone can explain that to me in the comments. I thought the two should be pretty much in line with each other. Nevertheless, it gives us some numbers in which to compare against. So I started off just setting the temperature for 20 degrees, just completely blanket 20 degrees across the whole day and night. And it did a really good job of holding the 20 degrees. But looking at the data for day one, which was literally just as the system was coming online, it showed a COP of 3.57, and this excited me quite a lot because the door was left open most of the day. So yeah, the house was really, really cold at this point, so it had to work quite hard to warm up the house. And to show that level of efficiency, that seemed quite impressive. Also, I did test it out. I did set it to 50 degrees, just as a fixed temperature instead of using the weather compensation curve, just to see how loud it got and things like that. Also, worth noting that the pipes weren't fully insulated at this point. This was something that happened on day 5 of the installation. Technically, this is day 4. But this is when it came online. So this was the first bit of data I had. So on to day 2 of operation, and it's another fairly good COP at 3.52. The system was online throughout most of the day. Again, doors were left open just as the final bits of the installation were finished off, mainly insulation of those pipes. In this instance, there was no heating needed during the afternoon because it was quite a warm, sunny day, but another decent result. But on to day 3 then, and this one puzzled me somewhat initially. So this one only had a COP of 3.39. Now at this stage, obviously everything was insulated, everything was all up and running, and normal usage patterns were in place. In fact, the day was nice and warm, which meant that no heating was really needed besides the early hours of the morning. So why was the COP only 3.39 then? The next day, it was a very similar usage pattern, and again, a similarly fairly low COP compared to what we were having of 3.27. So once again, only a little bit of heating used at the start of the day. But why these lower COPs on the days where we're getting less heating? Turns out it's because of hot water. We were heating our hot water between 2 and 5. We had it on for a 3-hour period, which I've since learned is far too long. It only needs to be around about 90 minutes, so I've shortened that now. But that was killing the COP somewhat. So hot water, the efficiency tends to be closer to about 3-ish on the COP, whereas heating can be a lot higher. In fact, for heating, I saw it as high as 4, just over 4 in one 30-minute stretch. On to the next day, and it looks like a good COP of 3.67, but this is without hot water heating. I decided not to heat the hot water tank that particular night, see how that affected things. It was a bit of a mistake on my part because I did run out of hot water on the second day. So I've learnt that lesson. But yes, that just goes to show how much more efficient heating can be compared to hot water. For the next day, I tried changing the target temperature thresholds from what was a flat 20 degrees. I made some areas of the day 19.5 in an attempt to see if I could make it run continuously a little bit more often, compared to the sort of on-off behaviour that you might see with it frequently trying to just maintain a set temperature. With the results being 3.42, I would say it's fairly inconclusive whether that did anything to help or not. Of course, the day was a little bit cooler. And on the topic of temperature, I don't find myself wishing for cold days very often at all. I like it warm myself, but I wanted to test what this Cosy could do. So a couple of cooler days was quite a good test case to see how much temperature outdoors did affect the coefficient of performance. And this day here gave us just 3.22, so it clearly did have a difference. But on to the final day, and you'll notice this is only the morning up to about midday, and this has a coefficient of performance as low as 3.03. So why is this one so much lower than the others? Well, it turns out that mornings are quite a bit worse for the coefficient of performance compared to afternoons and evenings. Temperature is a factor. It was a cold day, averaged around about 3 or 4 degrees, but there's more to it than that. Humidity is actually quite a big factor. So more often than not, you'll be getting a much better cup in the afternoon or evening time as a result of humidity. It really does make quite an obvious difference. The more humid conditions are typically found early in the morning, hence why you've got the dew, even on a hot summer's day, and maybe a frost in a winter's day. And that moisture in the air means that the heat pump has to work that little bit harder, hence why the efficiency takes a bit of a hit. That gives us a COP of 3.36 for the first week, which is broadly in line with what Octopus publish. It'll be interesting to see how this changes going forward when exposed to new scenarios and weather conditions. I've already gained some insights into how to maximise these, but for now, chasing the best possible COP won't be my immediate goal. Immediate goal will be to maximise savings, and that means heating the hot water at night still, even though that's the least efficient way of doing it. And that's just because of the cheap night rate on the Octopus Go tariff that I'm currently with. If you are looking to get a heat pump yourself, you can use this referral code to get £100 off any of the models, the Cosy or the Dakin from Octopus Energy. You don't need to be an existing Energy customer, and it also awards me £100 bill credit. I hope you have enjoyed this video. If you have, please leave a like, and if you are interested in more content like this, go ahead and subscribe to my channel. Thank you very much for watching, and I'll see you soon.